Welcome, Reiner, to the CMG interview series. This is the 16th interview in the series, which started during the group's 75th anniversary year, a couple of years ago. You can see the list of people we've invited to interview on the list on the Society website. And we're very glad to have you here today. So thank you for agreeing to be grilled by my questions.
Yeah, thank you, Kevin. It's really an honor to be asked to give an interview. So let's see.
Not at all. We're the ones that are honored. Okay, so these things follow a fairly well-worn path at this stage, Brenner. I'm going to ask you about your academic background, your school, university, and what led you to the career that you have, I suppose.
Yeah, I started studying mineralogy 1 year after I tested if I would be the right person to study informatics. But I realized university life was fine. Drinking beer with colleagues, being nearly 20 years old was fantastic. No parents were looking at me. But on the other hand, I didn't like programming. So obviously it turned out that I need something else. And by looking around, I realized that there was a mineralogical institute in Erlangen University. They have a wonderful campus. And within this very old campus, there were like 6 or 7 institutes. And one of them was mineralogy and geology. So I looked around there. It was just by occasion. It's like you kick a stone. And I saw, oh, Institute for Mineralogy, and asked these guys, what are they doing there? And they showed me the principles of the education. I said, okay, that's my thing. Not so many students, a lot of professors, and being outside in the country and learning details, just fantastic.
Okay. So you got all the way to second year in university before you decided that geoscience was for you.
Yeah.
All right.
So I passed 1 year studying more or less. I was also half a year in a factory to get some money because life wasn't so
Yeah.
cheap. So, but anyway, these were the days where you could still do it. I think nowadays this is no longer the thing you do. And after a year studying mineralogy in Erlangen, which had a strong focus on application on cement phases, and also a very strong crystallography education, I then visited Tübingen just to visit some friends, and I was flashed by this wonderful downtown of Tübingen, and I visited the institute there for mineralogy, and I saw they have a wonderful institute there. So I switched immediately to Tübingen and finished my diploma degree 6 years, 5 to 6 years later in Tübingen. So most of the time studying mineralogy was at Tübingen University.
Okay. It's interesting how serendipity plays such a role in things like this. You happen to be visiting some friends at another university and realize that they had a really nice course that you should go to. It was master planning or anything. It was just you happen to be visiting your friends.
Yeah,
that's cool. So
when you are young, you can do these things. Yeah.
yeah, indeed. You don't have any worries about mortgages to pay and things like that. So who was it at Erlangen and who was it at Tübingen who inspired you?
Yeah, Tübingen, the Erlangen was Professor Kutzel. He was the old professor for cement mineralogy. And when I listened to his education, that was just fantastic. And then going to Tübingen, there was, of course, the full bunch of different professors. There was one person that fascinated me. And in fact, it was, again, it was a Christmas celebration of the Institute. So I was there for just a few weeks. And we entered this room with everything prepared for a Christmas party. And Professor Friedrich Lippmann was standing there and serving wine. And I asked him some words in French. And then he started a discussion in French, although my French is not so good. But I realized he could have been discussing in 6 or 7 different languages because he loved speaking different languages. So for me, it was a big surprise that people can be also a person on its own, apart from simply teaching or apart from having simply a scientific life. So I realized this is a wonderful person.
Sure. Yeah, it's important to get a sense of people as humans as well as scientists, isn't it? Yeah, absolutely. Um, so you finished in Tübingen. What was next?
Yeah, next was Aachen University. I have to say, I was studying mineralogy, was a little bit annoyed that we only did this traditional way of education. We wanted to learn more about environmental mineralogy, application in environmental science. There was a field that was just popping up, but there was no university course dealing with this. They were not so flexible these days in this new university. And we looked over the fence a little bit and we saw that 500 kilometer more or less to the north at Aachen University, they started environmental days, and they had this is because Aachen University is always a strong focus on application. And in these days, in the early 90s, we had a big problem with too much civil waste, and there were not yet these possibilities to burn the civil waste. It has to be dumped in a waste dump, and there are new regulations, so people didn't know where to put the waste. And I thought, hey, clay could be a wonderful sealing material, and they already gave a full day of lectures. So we took a car, 5 people sit in this very old Passat, the VW Passat, and they were smoking all the time, and we were driving to Aachen, like you feel when you are young, right? And we slept somewhere in a bad place, but I listened to the talks there. And from one of these talks, this was my later PhD supervisor, it was Wolfram Echle, who gave a lecture about the specialties of ion exchange and other properties in sealing of landfills.
Yeah.
And when I listened to his talk, I said, this is exactly what I want to do. If he would be a PhD supervisor, that would just be the right person for me. It was more a feeling, like all the steps you heard before were already more driven by feelings and not simply by rationality.
So what year was that, Reiner?
Oh, that was 1992. So I saw these lectures in 1992. And then I gave my diploma work. We stayed for 3 months in New Zealand over winter times, which was these days a wonderful possibility. You know, I stopped working at university in Tübingen, and my wife, we were already married. We had a little bit of money came from somewhere, and we said, okay, we kill it all. And we were 3 months in New Zealand. We took an old car and just drove around and saw these wonderful places.
Beautiful.
With wonderful people in this country, and a lot of young people were traveling with us. I think this is the same situation, maybe more tourists today than these days. But it was wonderful to have this step out before being fully incorporated by work and family later on.
Sure. Yeah, it was a good opportunity to take, although I'm sure the amount of money was probably quite small after all those years as a student. But as you say, it came from somewhere. So
It
that, that,
came, yeah.
that's pretty cool. I think environmental mineralogy, I asked you about the year, was really beginning to roll in that 92, 93, 94 period. There were some key books came out, and I know in the UK we found the environmental mineralogy group and so on. It was a key time for that sort of research, wasn't it? I suppose the surprise is that we didn't do it sooner, really, when you think about landfill and the problems that it was causing.
Yeah, but at least in some universities started, and then it grew at certain places. So it was good. It was just good for at least for me in these days, and maybe I can say this also to younger people listening to such an interview. Just look around where you are interested in, and then follow what your heart is telling you, and just do it and test.
Yeah, I think you're right. I think when people go to a conference and they hear a talk that they find inspirational, I think it's those times you go up to them at the poster session or when somebody's got a cup of coffee and say, "Hey, can I talk to you about a possible career or
Yeah.
something?" It's and I think that's a theme we'll come back to in a little while is about leaning on those giants of the science when you're younger, and then becoming one of those in your case later on in your career, and finding ways to support the up and coming students. So what? Tell us a little bit about your work. Tell us what you're doing now, Reiner, for people who don't know you and what you work on.
Yeah, okay. But maybe I say just a few words about my time in Aachen. I was there for a little bit more than 6 years. And in Aachen, my supervisor, Echle, he just said, if you would be able to find a suitable method to get reasonable exchangeable cation values for clays that are used in applications and in soils, usually clays that have pretty much calcium carbonate, for example, or gypsum. If you are able to figure this out, how it works, that could be a PhD work. And that was all the description we had, right? And when I'm involved in like German Science Foundation proposals where we describe what we want to do to get money from the funding organizations, I see sometimes that at least, well, our introduction is like 12 pages. We can use them fully for the final paper that the PhD student will submit later on. So I think there's something, I will not say it's going wrong, but it was, if you talk to people who started in my age some decades ago, many of them say it was like this. So the professor told them, this is an idea, maybe you find your way through it. And of course you need some money. So I was lucky that there was some funding available. It was not much, but at least I could go start it.
Sure.
And in Aachen, it was fantastic to do all this because we were free to work, and there was already a colleague in our laboratory, Andreas Decher. He studied bentonite, so I had someone to discuss with. We had a laboratory to work, and then we made our way through it, and I finally had my PhD on ion exchange capacity, methodology, on clays and clays in soils and bentonite and whatever kind of application. And that was followed by 2 years as a research assistant at the university. So those we usually do in Germany, it's habilitation. Now it's junior professorships, but these days it was habilitation. And well, that was a new boss, a new way to work, and I realized that for me it was very important to give teaching courses at universities and to discuss with young students who came all of a sudden in my room and said, "Oh, you are now an assistant." They told me, "You can give me a small project of 6 weeks because I need that in my diploma work. So can you please educate me?" And the first one who came saying like this was Stefan Kaufhold, and the second one was Christian Ufer. And yeah, all the three of us, we had a wonderful time together, and we are all in Hannover at the time. So it is rooting really back to these days at universities where you can find clever young people. And that's a bit different if you then go to a geological survey. And that is now the answer to your question you had, which started more or less in January of the year 2000. I switched to the geological survey. And these days it was like, the big gift that you can get in Germany. We had many people who were unemployed. Unemployment was a big issue these days. These kind of postdoc positions were not so famous these days. I think this completely changed. You can find a job somewhere in the world if you are just past a good PhD work. But these days it was a little bit different in Germany, so it was just fantastic. I already had 2 children, 2 girls. They were 5 and 6 years old when we switched to Aachen, from Aachen to Hanover. So we started then in the year 2000 there.
Okay, well that was a busy period of your life then, obviously, to keep it all afloat with two young children as well. I mean, did you start working then immediately on rad waste, or were you doing some other work first?
That was automatically the first thing to do.
Okay.
So when I was running for the job, the people asked me, "Can you in future not guarantee, but can you more or less guarantee that you will be able to run a full quantitative mineralogical composition of clay cores that will for sure be at a certain time on your desk with many samples, for that you can make then a quantitative analysis? Do you think you are able to do this?" This was a question they asked all people, because in the late 90s and early 2000, it was not so clear that you can do this with Rietveld refinement. Steve Hillier was already around with his foot pattern method, so it was clear there is a way to really work nicely. And we wanted to do this with Rietveld, and there was a strong team in Germany at the German clay group, or German-speaking clay group. And one of the pioneers there was clearly Reinhard Kleberg, together with Jörg Bergmann in Dresden, and they were developing the first disordering models for chloride these days. And I saw his talk, and Reinhard, 1997 and 98, gave talks about this, and I thought, okay, this is the way it will be possible in future. You only need a good student who's able to work crystallography with a more or less a brain running on crystallography. I don't know how to explain it in better words. You need someone who's really clever in these things. And we found that Christian Uwe has skills on this. And so we found the right team to bring all these people together. And then you can see what I like very much to see when you work with young people, work with PhD students or postdocs, that after several weeks or months, you see it's like an aeroplane that's starting, and you only see, okay, this guy's on track now, and this will be a wonderful project.
Yeah. Well, that's lovely to see that. I mean, I presume you're at least partly responsible for putting them on the runway and getting them up to the right speed in order to take off to continue that analogy. But
well, Kevin, my role was more or less bringing the people together, because I
sure,
love networking already these days. And I saw the demand to have someone to run such a Rietveld methods of fundamental parameter disordering models. That was a request by Rainer Kleberg. And I was in his laboratory, and I knew immediately I have to ask Christian, maybe he likes it. And the Professor Roth in Aachen, who as a pure crystallographer, was able to think in these systems, not only in phyllosilicates, but also in other kind of materials. So adding material science and people who are skilled in one boat and then letting it flow. I was just, it's like waving and looking what's going on, giving some ideas, but that was fantastic to see. This is maybe one of the best decisions to bring these people together.
yeah, the German contributors to that work have been an incredibly strong part of the international effort. I think yourself included. I think it's been a really strong period of development in that subject, hasn't it? Internationally, Steve and colleagues in the United States and so on. Steve Hillier, I mean.
There's a reason why I like fundamental parameter Rietveld models, and that's not only one software, but now it's freeware, which makes life really easier worldwide. The big thing is for me that if you are skilled enough, many different people can use these techniques and get more or less the same results.
Sure.
Whereas for some techniques, you have to be an expert. So you have in the let's say the bad old days, right? In the 1990s, for example, we had like 2 dozens of experts sitting worldwide, and they were able to write down numbers to make something like 100% of quantitative clay analysis. And of course, they made some double checks with chemistry and other parameters. But here now we have really physically based methods working with atomic coordinates and elemental cells. So what I like really much here is that many different people can do it, and it is physically really meaningful.
Very, very good. Reiner, to go back to the subject of radioactive waste management and disposal,
Yeah.
where do you think we're up to internationally in all of this? That sort of research has been going on for more than 20 years now, probably longer in reality. When do you think we're going to see waste being put in the ground routinely around the world?
Yeah, I can say that first of all, I'm really happy to see, because I was in the middle of all this for many years, but just by occasion, because I was one of the few guys in Germany working on clay and red waste more than 20 years ago. So I was able to be part of the so-called scientific committee of the clay red waste conference series that is running parallel to our other clay conference series. And that was driven by colleagues from France. So Patrick Landais was the driving force, and he was clearly someone who said, "Okay, we write a lot of reports, and we need really sound basis of scientific understanding and acceptance, and we need more scientific discussions." So he developed, together with a few other implementers, so those institutional bodies who were responsible to plan the red waste repository. So with the other implementers, they were setting up this conference series. And then already the first one in 2002 in Reims was a big success. We had nearly 500 participants and that developed over time. And I have to say that in the first 2 or 3 meetings, colleagues came who were usually also at clays and clay minerals, or clay minerals, Euroclay, or whatever kind of conferences. Most of them I knew from Europe, of course. And we were, part of us were at the conference, and we were looking at 2 different kinds of qualities. The one quality was the one we knew from our normal clay family conferences or national clay group meetings. And then there was also a kind of quality that we thought, okay, I think we have to teach them first, right? So there was the quality was not so good as an average in the first 2 conferences. And that dramatically improved because people realized, the organizers realized that this has to be improved as well. And then starting with the conference number 3 or 4, this level was absolutely on top then. That was nice to see. This all was accompanied, let's say like this, by an OECD nuclear energy agency driven institution. That's the so-called Clay Club. The official name is too long. No one calls it like that. It's an international group of the safety case, blah, 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 working group on agalicious clay formation. So Clay Club is something that describes what the people are doing there. And there were implementers and regulators and university members, and sometimes also consultants to bring really complicated question into a report. And this group was continuously working twice a year together with the Monterrey project. So we had like 3 different bodies that were all at the same time pushing the basic understanding of clays in red waste systems forward, but using these different formats. And when you're going to the meeting, you saw, okay, yeah, I know about half or a third of these people from the other meetings. So there was a relatively small group of people who really wanted to have a better understanding on clays, who were driving this forward, in most of them from Central Europe.
Okay. You didn't answer my question though. Is when are we going to start putting red waste in the ground?
When we going to start?
Yeah.
Okay. Yeah. Sorry, I was
Routinely.
too
Yeah.
much in this other.
Yeah.
When we're going to start? There are some countries that are further in the licensing and industrialization process than other countries, for sure. Germany was quite far when they were looking for salt, and now they switched back and they started again, so they are not so far at the moment. Finland, for example, has the most advanced project. Finland uses bentonites in crystalline rock. So bentonite behavior is a very important part of the whole barrier system to understand this. Some other countries like Sweden are also on a relatively strongly developed track with respect to licensing and then putting it finally in the underground. Whereas other countries, they still discuss and have very, very long project plans. So if you ask me directly, when will we have the first one in clay rocks in the underground, so not in crystalline rock with bentonite barrier, really in clay rock, I see the first one will maybe be built in Switzerland or in France.
Okay. Yeah, it's an interesting question, isn't it? Because not alone. I mean, to go back to bentonite and crystalline rocks, the other geology matters as much as the bentonite, and the canisters matter as much as the host rocks and the bentonite. And you've got geopolitics to throw into the mix as well. So it's a complex question, isn't it, to answer? And I apologize if I put you on the spot, but it feels like it's a long haul, doesn't it? That we've got a long way to go.
Yeah, this is when I have something like young people entering our laboratory and then they ask me, what are you doing? What about red waste? And I always tell them, of course, this is an ethical question. You first have to ask yourself, do you want to work on clay red waste as an application because of the ethics? And on the other hand, the waste is there. So we have to find a really good technical solution. So, but there's no clear way how to say it. It's just think about it before you start working on this.
Sure.
But at least I think it is for future generations important that we find a good solution and bring it down now. Also because of political stability that
Yeah.
10, 15 years back, if you say something like, oh, look at the political stability in Central Europe, it is good that we will be able to bring it down in a few decades. And most people said, no, no problem. We have wonderful stability. If you say the same thing nowadays, yeah, maybe it's good.
Not so stable. Yeah, yeah, agreed,
Yeah.
agreed. Um, in your view, what's what's one of the for you, what's the biggest question to be answered before we can make decisions about the subject we just mentioned? What's the biggest clay question, should I say?
The biggest clay question. Well, clay rocks that are foreseen as a repository for radioactive waste, they are usually at least 100 meters thick. They may be in some occasions also much, much thicker. And of course, you have a large heterogeneity simply by the sedimentary origin of the materials. So if you look closer and closer, the more heterogeneous it becomes, right? What you need is somehow to make a prediction over something like a 10 centimeter unit, because if you then have these decimeter, you can scale up to meter and then to a borehole length. And this has to be bridged between the atomic level and this decimeter scale. And to find something that is scientifically sound in a physical chemical way, and also to include aspects of geomechanics, for example, and fluid flow, that is to integrate that in a physically sound or physical chemically sound way. This was for me the big challenge.
Okay, so just a small question then.
Well, but this is only for red waste.
No,
I would
it's a
say
that's a huge question. Yeah,
if you switch to more general question on clay science, I see a lot of possibilities when working with soil community. We have like 1,500 members of the APIA umbrella group of all national clay groups, and this is just a small organization if I compare it with the International Union of Soil Science.
sure,
They are much much larger in size, and many of their processes are driven by reactions on mineral surfaces. And mineralogy, bringing mineralogy really back with our skills, how we do it in our clay community, back to soil science, and do a lot of research with these people together. And you need a lot of people from us to give them the kind of quality of characterization of the material.
sure.
So it's not an easy task, but it would be worth to find a solution for this, because the application in agriculture and preservation of soils in future, that's a big
It's huge,
demand.
huge. Yeah, absolutely, absolutely. Going to change tack slightly, Renner. As you've moved through your career, you mentioned to me you were really flattered and delighted to be asked to serve as an associate editor for Clays and Clay Minerals. You've obviously been involved in organizing various meetings, Radways meetings in particular over the years. You've an active role in the German Clay Group. It's clear that giving something back to the community is important to you, and of course, I suppose this was recognized most significantly by your appointment, your election as the president of AIPEA a few years ago. Do you want to talk a little bit about that part of your career, about the importance of finding ways to support early career scientists and so on?
Yeah, this is something each person has to find its own way through this. What we can offer in our national clay groups is a kind of family feeling. For those of that, I saw some. I was present at some relatively large clay red waste project meetings, like Belbar in Berlin. That was 10 years ago, roughly. And I saw 40 people, young people, and also senior colleagues from 10 different countries. They were sitting on a table, they're discussing the whole day about liberalization of clay particles with respect to the barrier safety questions. So there was a lot of science from different disciplines, but none of these people were were had some glue, like a clay family, like we have like the clay minerals group from UK and Ireland, from clays and clay minerals in sorry, not clay minerals society, I mean from the United States and North America in general, and also all these many different groups in the European Clay Groups Association and the Asian groups as well. So I saw, okay, this is a lot of potential to bring these people together and continue working, but they don't continue usually. They simply then flip to the next project. So we may never see them again. And this is very much different in national clay groups. You see people usually again and again. Of course, PhD students are supported by the supervisors and also by the national groups, because these people have to find their way to be then to finally get the PhD degree. But then after being PhD, you're more or less lost in a basin of sharks, or however you want to call it, or in a bath with good friends. It depends how people feel when they are in such an environment. But we thought in APR, as you already mentioned, we thought that it would be good to give early career scientists a new home. And we were not the first ones who had this idea. I have to say, I was inspired by the International Association of Sedimentologists. There was a meeting in Canada 5 years ago, or no, 7 years ago. So I was there, and I saw that there was a professional group. They were discussing all the time. All individual people were running around at posters, but there were like a crowd of 25 people, and they had these short presentations, 2 minutes or 3 minute presentations, and one was standing up on chairs on stairs after the other one. I was looking there with my beer and said, "What are they doing?" And then I asked one of them later on, when I saw them several times during the meeting, and I said, "Yeah, we have an early career group." And next year in Rome at the same conference series, there was a tiny place, not this huge meeting like in Canada with a big hall, right? A tiny place. And I again saw the same people, and I said, "Oh, are you going to plan meetings of the early career?" And the colleague I already knew from Canada said, "No, I'm out now. I was 5 years in this early career. Now I have my network, and I gave my position to the next person to build up an own network." And he was smiling, was so happy. And I saw how these other new people running around, and said, "Okay, I think we should do this in clay community as well, because these people can then interconnect with a network, and at the same time they can work back into their national clay groups, right?"
Yeah.
So it's positive for them, and it's also a positive outcome for the national clay groups, that their skilled young people are involved in networking, and then maybe continue doing the same in the national clay group. And that was a basic idea to do it.
It's a great breeding ground for future leaders of national groups and international groups, isn't it? Yeah. I've recommended it to some colleagues in another international society to look at the early career clay scientist network as a model for how to create that sense, that family sense, as you describe it, and hopefully they'll get that going, because it's really important to offer that support network and places for people to talk. The online seminars for ACCS has been, I think, really beneficial, and it's a great initiative. I think you underplayed your role a little bit in all of this, because not just AIPEA, although I would say to you that AIPEA flourished under your leadership, because international bodies are fantastic, and we have to have them, but they can be quiet and they can be reserved and rely on the national societies. I think that was reversed a little bit with you and Saverio and others leading AIPEA.
Yeah, we had the chance to have these new communication techniques. Yeah. I was looking back in the record of APR over the last 40, 50 years, and I saw that these days you wrote letters, and of course people received the letters and they were answering on using a letter. So there was very serious and positive communication, but not so much, right? And now with video meetings that expanded, being possible, maybe driven by Corona, which is one of the positive outcome of that, is that we have video meetings everywhere, and we use this extensively and made our networking. So a networker without someone to communicate means nothing. So it is also a question of time.
Yeah, yeah, I think so. And I agree with you. I think we've had few enough legacies, positive legacies from the pandemic, but the ability to meet like we are now, or in larger groups online at essentially zero cost has been one of them, I think. Um, I wanted to touch on you brought up the subject of soil science and clays and soil science in particular. Um, and as you know, at the recent International Clay Conference, we had a strong session on soils, and in which we paid homage to Jackson and his role in clays and soil science. But it's certainly one of the areas where we're seeing fewer scientists involved, and certainly one or two of them said to me during the conference, "We're a small group these days." Um, on the other hand, uh, I for one felt at the Dublin meeting that there was a even wider range than before of subject matter. I remember in the 90s, all of the papers I was reading about clay science were about illite smectite, it seemed to me.
Mm.
Um, we had 40 or so sessions on different topics. Do you want to comment on how that's changed, and maybe to some extent to the detriment of fundamental science, actually?
Yeah, I think the understanding of illite smectite development was fundamentally important for our development of skills on X-ray diffraction techniques to finally then quantify the minerals in all these different systems. And most of that was driven by the oil industry. So they put these days a lot of questions along with a lot of money into our scientific conference series, by giving people projects, and the colleagues then developed new ideas how to improve the interpretation in the end to have a better recovery of oil and gas by different drillings, because the drilling campaign is extremely expensive. So I like it very much that we now have this basis of understanding of elitization. And of course, these days I can imagine that there were a lot of contribution at the meetings. So elitization over and over. And I can say that when we started with working with the Clay Redwest community at small project meetings of the Swedish implementer, Stefan and Kaufeld and me, we came to this room, and it was not our meeting, but we already listened to what these people were saying, and they all were modeling elitization. And then we asked carefully, "Oh, did you ever analyze a sample? Did you really find elite, or was it simply collapsed interlayer?" And then over the years in the clay red race, as I already said, the quality improved very much about really the interpretation of what you have in experiments, and also what you can interpret it. So most of the contributions disappeared, talking about that it is clear that if you model such a system, you always get elitization. So elitization was a driving force, and it has its peak, of course.
Sure.
We are now much more international, much more interdisciplinary in science. And I have to say, what you saw in Dublin, I can add something. When we were at the Euroclay conference in Paris, that was 2019. My role was to support the opening ceremony, because these days I was president of APR, so it was clear at the Euroclay meeting, some of the old guys have to stand up and say just 1 minute of words. And when waiting for this opening, I was sitting next to the vice president of the Pierre et Marie Curie University of Paris, right? So this is one of the most famous universities worldwide, and he was sitting there he wanted to open the conference in the same way as me, but disappeared later on because he had much more jobs to do that day. But he told me that when he listened to what the organizers are presenting, he realized that we were working completely interdisciplinary. And he said, "I would like to have this in all institutes of my university."
Wow.
Right?
Wow.
So that was okay. I did not have to add something like this. So I think this is the big strength of our community that we are working interdisciplinary, because we all don't really understand how our clay minerals work. And by asking someone from microbiology if such a person can explain my clay barrier performance a little bit better, I learn all the time. This person is asked the first time about red waste and gives an idea of what he or she is thinking about their own system that could support
Sure.
our basic understanding, and that's fantastic.
Yeah, wonderful. Agreed. Agreed wholeheartedly. Reiner, what's your favorite clay? I think I know the answer to this question, but what is your favorite clay?
Well, I have to say, this is what I'm working with is favorite clay. I mean, the application of clays and redways is, especially in Germany, but also in many other countries, is something that's really important. So therefore, I like clay rocks in total. And of course, I like bentonite. So I
Bentonite.
would not concentrate it on a mineral. I would concentrate it
Okay,
more
fair.
on an application,
Fair
right?
enough. I should have said what's your favorite mineral, not what was your favorite clay mineral, but I suspect the answer might be the same. But anyway, yeah. And if um if you were interviewing somebody for this series, who would you interview? Who were your heroes?
Yeah, my heroes. So I would go back, and I would really like now, after having had discussion. I met David Bish last week at a
Ah,
workshop, and we talked about our professors that we were educated by, and told him about Friedrich Lippmann. He said, I know this guy because he's still in the age that he met him at conferences like William Jones. He also told me that he knew him. So I would really like to interview him. I would also go back in time, nearly 200 years, and that was a farmer from Yorkshire who recognized that soils have an ion exchange
ah,
ability, right? And or maybe his colleague who published 2 years later isotherms and had more than 96 experiments in this paper in 1852. So
wow.
just fantastic to speak with these people. I have like a handful of colleagues, and I would also like to, with one of my really good friends in the scenery is Peter Kumadel. I would like, if I could go back in time, I would ask him to give an interview.
Yeah, so would I. I think yeah, Peter's a friend of mine also, and it would be nice if he was still with us, wouldn't it, to do something like this. Reiner, what do you do when you're not working on clays? And I know you spend an awful lot of your life working on and thinking about clays, but what do you do in the rest of your time?
Oh yeah, we have of course family,
Hmm.
so I spend a lot of time with my family together. My parent is still my father is still living, so he's 91 and going to be 92 in a few weeks. So
Wow, fantastic.
I'm very often sitting in a car and driving to all these places where the family lives. So
Sure,
that's basically what I'm doing.
what you do. Okay, well, that's value for sure. That's a good thing to do. Ryder, I think we're going to call a halt there. We're about 40 minutes in, so we should call a halt there. It's been lovely chatting to you, and I'm really glad I've had this opportunity to talk to you as one of my heroes in this subject. I think you're an example for us all to follow, if I can say that. So, thanks very much.
Yeah, thank you, Kevin.